Hello, and after a rather long enforced break, welcome to this vSuite version 0.4 video tutorial. And in this video tutorial I'm going to cover sort of the initial steps in doing an EnergyPlus simulation. So this video is just going to cover the basics of using the EnVi component of the vSuite. And EnVi is a bit of the vSuite which can specify, control and then visualize EnergyPlus simulations. So in this initial EnVi video, I'm just going to start off with a more or less default scene. I'm going to get rid of this lamp because I won't need it. I'm going to have my, I'm just going to take my initial default cube. I'm going to move it up. I'm going to scale it a little bit. I'm going to take the roof and raise that up a little bit. I can create a little bit more complex geometry if I want. I can inset into some faces to create some very simple windows within the walls. Remember that the green arrow Y, that's north, so I've got one window there and I'll have one window on this south face as well. And move that maybe a little bit over here. So a simple room, maybe a room part of a larger building, but whatever, we just want a single space, a single zone right now to do a very simple EnVi simulation. So that is the geometry of that zone kind of done, I think. So I'm going to come out of edit mode and now I have to apply to these faces that I've created materials, and I have to also designate this blender object as being an EnVi thermal zone. So I'll do that first. I'll come over to my object display panel over here, or object data panel, sorry, over here, and I come down and I'll see this option down here, vSuite object definition, and in there I pick EnVi zone. And once I've picked EnVi zone, I could set this as a thermal chimney. I could set this as shading geometry, but the default is thermal, so we're going to do a thermal analysis on this zone, and that is the analysis I want to do this time. We also have some options for inside and outside convection coefficients. Details of those, about those, are available within the EnergyPlus input-output reference manual. For the moment, I'm just going to keep these both at default for this simple simulation. So once I've set it to EnVi zone, the vSuite now knows that this object is going to be a thermal zone in EnergyPlus. But I do now need some construction characteristics to go along with these geometric faces. So if I come into my material tab, I'll see that because I've used a default cube, which has already got the default material associated with it, this material is now applied to all the faces. Even these new faces that I created, they've picked up this new material definition. So this existing material, I'm going to call it walls. And if I scroll down to the bottom here, I will see EnVi construction type. If you haven't selected this object as an EnVi thermal zone in the previous step, this menu won't appear. So for the walls, I'm going to pick the wall type, and I've got various options here. I've got whether the wall sits on a boundary between two zones. As I'm only doing one zone in a simulation, we leave that unchecked. We can specify whether the surfaces that this material is associated with are airflow surfaces, so they allow air to move through them in a natural ventilation schema. I'm not doing natural ventilation here, so I'll leave that unchecked. And we've also got a button here for thermal mass. So if the surfaces that the material associated with don't sit on an external boundary, or we don't expect much heat to flow between or across the material surfaces, so we're not expecting a warm inside, a cold outside, and heat to transfer across. All the surface is doing, if we click thermal mass, is that it's absorbing heat and it's giving away heat in the way that thermal mass does. And if that doesn't make any sense to you whatsoever, then you can go and look up thermal mass on the internet. But it's for like stuff inside a room. Sometimes we use concrete, sometimes even water within spaces to provide thermal mass to kind of slow down the way temperature changes within the space. Those kinds of things we turn on thermal mass, not boundaries where we want heat to flow in and out between one zone and another, or between a zone and external. That was a much longer explanation than I intended. The upshot of it is I'm not going to click this now. Construction makeup, we can have a preset construction makeup from a sort of rather limited vSuite database. We can construct out of layers our own, again from the layers come from the database, but we can construct our own construction based on these database layers. But we can also create custom layers as well. And there's just a dummy here just to turn off that particular material and the surfaces that that material are associated with for any particular simulation. So for the walls, I'm going to go with preset, and I've got sort of a passive house construction here. I've got a standard external wall construction. This is standard for the UK. So I'm going to pick this, but there's something important to note about these menu items here. If I pick different preset constructions, I will get a list of different layers within those preset constructions, and the default millimeter value is always the same. It's always 100. It makes it easier for me to code EnVi if I leave all these at the same value by default. What then happens is, for each particular construction you select, it will tell you what the default layer thicknesses are for that construction. So instead of being 100, 100, 100, it's 100, 200, 100 for this external wall case. So I'm going to make that 200. So this is important because picking the construction isn't enough to specify necessarily correctly the layers within that construction in terms of thickness. So always bear in mind these numbers, and I mean you can have whatever numbers you want in here. These are only recommended values for that external wall construction, but pay attention to these before just blindly picking a construction makeup and then doing a simulation with it. So that is the EnVi construction setup for this wall material, which is currently being applied to all surfaces within this zone, but I don't want it applied to all surfaces because for a start I've got some windows in here. So let's come into edit mode again. I'm going to pick those two windows. I'm going to add a new material slot to this object. That new material slot will be highlighted by default. I'm going to assign that material slot with this assign button to these two window faces, and then I'm going to add a material to the material slot, and I'm going to call that window. I'll come down here, and now instead of wall I pick window. I've got the same kind of preset layers. I'm going to go with layers this time. Outside layers, going to pick it from the database. Clear glass 3mm. Again, we default to 100, so we want to put in 3 in there. We're going to have an air gap. And I might have an argon fill, 12mm, and my third and final layer going to pick it from the database again. Glass 3 mil, 3 mil. So 3 mil glass, 12 mil argon, 3 mil glass. We can have, with this current next version of the V-Suite, will move to a nodal interface for material definitions. But in this current version of the V-Suite, we can have up to 5 material layers associated with a construction. If you want to have more than that, I recommend that you amalgamate the physical properties of 2 layers into one, or 3 layers into one, to represent your total construction performance with 5 or less layers. So that's the window specified. I'm going to have a material for the roof. So again, new material slot, assign it to the roof. New material in that slot. I'm going to call it roof. And as you might guess, I'm going to pick now roof material. And yeah, I'm just going to go with the default now, which is 25, 100, 25. According to these recommended values. So that's the roof done, and now finally I'm just going to do the floor. New material slot, assign it to the floor, new material in that slot, call it floor. And so the pattern repeats. Pick floor as a type, and I'm going to have, yeah, I'm just going to have ground floor. So put in my new values. That's now the floor done. Now I'll say something about the floor while I'm here. The V-Suite, when you have something designated as a floor, or in fact when you have any surface within a zone, within a Blender object, any surface, if its midpoint is below the ground plane in Blender, or the z=0 plane in Blender, it will assume that the outside boundary condition is the ground. So for this floor, because it's on the z0 plane, the V-Suite will assume that outside of this floor is the ground. For these faces here, because their midpoint is below, above the z=0 plane in Blender, it will assume that the outside boundary condition for these faces is the external air, unless I turn on intrazone boundary for any of the materials. So that's just a note about what the default outside boundary condition is, depending on the position of these faces within Blender's Z axis. So I believe that I have now specified all the faces of all my materials with all my materials that I need. I can, if I want, within the Blender scene, if I just go over to my cycles rendering engine, for my different components I can, if I want, give them different colors, just so I know that each floor or each surface is the thing I want it to be. So I can do that now, and I can see, yes, my windows material is associated with these faces, my roof material is associated with this face, etc. But when we export this, the V-Suite will also do a check for us. So let's go and export this Blender geometry into Blender geometry more suitable for an EnergyPlus simulation. So I've got my node editor open up down here, and I've got my V-Suite VI network node tree group associated here. I now want a new node tree within that window, and now I can add a process node, EnVi geometry. So there are no options here. There might become some at one point in the future, but at the moment they're not necessary. So we can just press export, and it's reminding me that I have to save my Blender file. So let me just do that. So now if I export that, nothing's changed here, but we'll notice I've constructed my geometry on layer 1. These are Blender's layers, 20 in all. I've constructed my geometry on layer 1. I now see I've got something on layer 2. And layer 2 is a copy of this original geometry. This copy is made during geometry export. And now we have specifically colored these things, these different types of surfaces, according to a schema. So if I come back into here, if I, for example, make my windows red in my original geometry, if I export, we'll see that whatever color I made things in the original geometry, when I export that geometry, it's colored according to a particular schema. Green is roofs, brown is floor, turquoise is windows, grey is walls, red is shading. I think that's all the color. So if here you don't do a coloration check and you just create surfaces and you associate materials with each surface, and all the materials have the same color in Blender, so you don't know which one has been associated with which one, then you can see it here after the export stage, where that coloration gets done for you in effect. Now this geometry on layer 2, it's not really intended to be edited. It's only really there as a check for whether you have associated the materials to the correct faces, and that those materials are of the right designation, roof, window, wall, etc. Sometimes the geometry that gets created by the v0.4 EnergyPlus has some errors in it, or is not sort of valid EnergyPlus syntax, and it might be that you have to make some changes on this layer 2 geometry. But in general, this is just a check, and we do all our work on layer 1 or whatever layer we're working on. So I've now exported my geometry. I now need a context. For the context, I'm going to need a VI location node, and that VI location node should have an EnergyPlus. We're doing an EnergyPlus simulation, so it's no surprise that we need an EnergyPlus weather file. And we also need, now I might just expand out this window, and we also need an EnVi context node. Our geometry goes into our geometry in, our location goes into our location in. And once those linkages have been satisfied, our export button appears here. Now in this context node, we have some options about whether we're going to do a parametric EnergyPlus analysis, which I'm not in this particular video. We can set kind of a name for the project if we want, and this will be the name given to all the output files that we create. We can specify what the terrain that the building sits in is in terms of sort of wind exposure. So I'll just stick with a city, sheltered exposure, start day of the simulation, end day of the simulation, time steps per hour. It's alright if you're going to do just a pre-run sanity check, 1 is okay, but 4 is kind of the usual recommended minimum. So we're doing a simulation every 15 minutes. And then we have to specify what kind of results we want out of the simulation. Now in this video I'm not applying any heating or occupancy or any of that stuff. So most of this won't apply, although we can have temperature, because there'll always be a temperature, and we can also have fabric heat balance, and we've got some windows, so we can have solar gain as well. So that's the context creation done. So I click export, that node should go grey, and then once we have exported, we have created an input file for EnergyPlus, and that input file is a text file. And once we've exported to context, we can see that text file If we switch to Blender's text editor, we now see this in1 IDF. IDF is the suffix for the input description for EnergyPlus. In is for input, 1 is for the frame that we're currently working on. So if I just switch back to my 3D view, you can see we're currently in frame 1. So if I go back to the text editor, so this is now the EnergyPlus input file that we're going to use, that we're going to simulate with EnergyPlus. Now you can change this within Blender's text editor. You can, after export, you can change this file. So you can put in a different positional point for a building surface, for example. You can add custom elements in that aren't dealt with currently by the V Suite, etc. You can change it in here and then you just save it. To do a simulation, now we add an analysis node, EnVi simulation. We drag this context in here. Now this EnVi simulation node will actually read the text file. So if you've created a text file with this node, then edited it within a text editor, this EnVi simulation node will see the edited version. So I'm just now going to press calculate, and that was very quick. My Kiwi window popped up and then disappeared again. I might just, let's make it 10 times nets per hour. It's fine, I'll press calculate. You can see my Kiwi window pop up with a progress bar. It's a pretty quick simulation because it's only a simple single zone. And once that's finished, at the bottom of this 3D view panel, I've got my V Suite display tab, and I've got some options in here. I could pick static or parametric results visualization, but as I've only done a static analysis here, I've only got static available. I can pick to visualize a subset of the simulated day range if I want, but I'm going to stick to 1 to 365 here. And I've got some advanced experimental options here about visualizing ambient conditions and visualizing zone results. But I will leave those turned off for the moment, and I'll hopefully talk about them in a subsequent video tutorial. So I'm just going to go ahead and press EnVi display, and you'll see that we now have here a menu to pick which of the results we chose to simulate, which of the parameters we chose to simulate. We have a menu here to pick color scale, and we have minimum and maximum values for each of the 3 results or parameters that we've simulated. Now these influence the scatter graph that now appears within the 3D view. So if I just expand this out a little bit, we can see that currently I've got temperature selected here, and so this is visualizing cube temperature. I can switch over to solar gain. When you change stuff here, you usually or often have to put the mouse over the icon to update this graphic. So solar gain now, for example, we can see I've got a legend scale of 0 to 200 for solar gain. So I might increase that a little bit to 500. And we can see our solar gain coming in during the middle of the day. Solar gain is expanded slightly in summer as the sun is above the horizon for longer than in winter. We could look at the temperature within the zone, and I put that to 25 as a maximum. We can see generally low temperatures in winter, higher temperatures in summer, but because there's no ventilation in this zone, so the temperature only changes because of heat being conducted through the facade, either inwards or outwards, that high temperatures within the summer can be maintained within the zone even at night time, early morning and late at night. I should say that this color map graph has days along the bottom and hours along the top. So day 1 to day 365, hour 0 to hour 24. We can look at heat balance as well. So this is the amount of heat coming into the facade or leaving the facade. So we have higher values during the day where heat tends to be entering into the zone, and we have lower values in the evening where heat tends to be leaving the zone. And we also have here, oh, that's only just updated when I put my mouse over the icon. We also have here some tabular data, and this is for the particular zone we have selected. So if I don't have a zone selected, or if I was to say go into another zone, go into my layer 2 with my pre-checked geometry, if I select that, I'll have invalid object up here. That still stays the same with the old selected, but this one will say invalid object. So you have to make sure you have your layer 1 or original geometry selected, and then we get tabular display for this zone. So the minimum heat balance, solar gain, temperature, average and maximum, and the percentage below or the percentage time above these thresholds. So at the moment, temperature, it's 35.5% of the time below 16 degrees Celsius. So if I change that to 12 and I click on my table and I change temperature here, then when I put my mouse over the table icon, we can see that it's only below 12 degrees Celsius for 3.2% of the time. So this table does live update with these percentage times depending on these values, but you have to have here changed, have here selected the one you are currently changing. So if I am on temperature and change solar gain maximum, that doesn't change the table, but if I go to solar gain, that now changes that solar gain value. So those are the kind of 3D view visualization options. We can also, as we now have a results out socket on this EnVi simulation node, we can add a vSuite chart node, and in this vSuite chart node we can pick, as in the sort of very early video tutorial I did about the vSuite chart node, we can pick day range, what kind of chart we're going to plot. I think it's only line scatter available at the moment. And we can pick for the x-axis just time. On the y-axis now we can pick either climate, or we can have a second y-axis and we can pick zone, and we can pick temperature and temperature. We can plot that. That's just off my video recording screen. But we've got then ambient temperature and zone temperature. We can pick a subset of the year to chart if we want. That's the first 12 days. We can go to a daily, so we plot one value for every day, but now we have to pick whether we want the maximum or the average value for that day. So they're the average daily values, ambient and cube. We can also pick if we want heat balance. So there's ambient temperature, there's our heat balance, etc. Pick our solar gain, pick our direct solar. So we can see here ambient solar, direct solar going up, and the solar gain in the zone going up as well. We could, if we wanted, plot climate, direct solar against zone solar gain. We can now see that relationship between the two. If you don't want to have a line graph in here, then this is a matplotlib window, which is a Python library for graphing. And in here we can change whether we want do I want to have an octagon? Whether we want a line or just symbols, etc. And also the sort of final visualization option. We have a vSuite CSV file node, and we can now export that CSV file, and I can open up my text editor and I can open that CSV file, test CSV, and we can see along the top we've got, for each frame, I'm simulating frame 0 now, for each frame, each of the metrics, and then for the whole year, each value. So that can be useful for plotting out to third-party graphing applications or doing other manipulations of the data. So I think for an initial video about EnVi EnergyPlus simulations, I think that's everything I have to cover. There's always something I forget when I finish recording a video, but I think that's everything. So yes, okay, thanks for watching.